Hello children, in the last class we had studied about the chemical trends of the group 15 elements. So in this we had explained that the reactivity of the group 15 elements towards hydrogen, and for today we start the reactivity with oxygen and the reactivity towards oxygen. So the elements of group 15 form two types of oxide children. One is the E2O3 and another is E2O5. These two types of oxides are formed by the group 15 elements, and here E is the element of group 15: nitrogen, phosphorus, arsenic, antimony and bismuth. And the oxides in the higher oxidation state is more acidic than in the lower oxidation state, and the acidic behavior of the oxide basically decreases as we move down the group. The E2O3 type oxides of nitrogen and phosphorus are purely acidic in the nature, that is the N2O3 and P2O3. These oxides are nearly acidic in the nature, while the oxides of arsenic and antimony are amphoteric. Amphoteric means they behave as an acid as well as base, and the oxide of the down element, that is the bismuth, are completely basic in the nature. This is the reactivity of the group 15 elements towards the oxygen children. Next is the reactivity towards halogen. So the group 15 elements combine with the halogen gas X2 to form two types of halides. One is the EX3, it forms trihalides and pentahalide. Okay, that is the NCl3, PCl3, PCl5. So these elements directly combine with the halogen to form trihalides and pentahalides, and all the trihalides are stable except NBr3 and Ni3. These are basically unstable compounds, whereas all the trihalides of the group 15 elements are stable and they have pyramidal shape. The group 15 halides, that is the EX3, has basically pyramidal in the shape and they are easily hydrolyzed by the water. Here one important point to note you down children, that is the nitrogen does not form pentahalide, that is the basically question comes like that is the NCl5 does not exist, whereas PCl5 is known. Why? Because the nitrogen is a small size element and there is an absence of vacant d orbital in its valence shell. That's why the nitrogen does not form pentahalides, due to the absence of d orbital in its valence shell, whereas the phosphorus, arsenic, antimony, these form pentahalides, whereas the bismuth does not form the pentahalide due to inert pair effect. The inert pair effect is already explained in the previous class, and all the pentahalides have the sp3 dehybridization, and the shape is trigonal bipyramidal. The shape of the pentahalides are trigonal bipyramidal shape. These are the important points about the reactivity of the group 15 elements towards halogen. Next, discuss about the dinitrogen. Dinitrogen, this dinitrogen exists in the form of N2. Next is the dinitrogen N2, and it exists as a diatomic gas in the elemental state. Therefore, it is named as the dinitrogen. So first we discuss about the important preparation of the dinitrogen. These three are the important preparation of the dinitrogen. In the first preparation, it is prepared in the laboratory by treating an aqueous solution of ammonium chloride with sodium nitrite. So you see here children that the ammonium chloride, if we take the aqueous solution of ammonium chloride and it is treated with the aqueous solution of sodium nitrite, and after the reaction the nitrogen gas is liberated, dinitrogen, along with the liberation of NaCl and along with the water molecule. So this is the first preparation, that is the preparation, this preparation is carried out in the lab. Next preparation is second preparation, and it can be prepared by heating the ammonium dichromate. So when we heat the ammonium dichromate, it decomposes into the dinitrogen, water plus chromic oxide. Next preparation is and with the help of this preparation we can prepare very pure nitrogen, dinitrogen, and it is obtained by the thermal decomposition of barium azide. So, or at the place of barium we can take the sodium azide. So, by this preparation when we heat this barium azide, it gives the barium along with the liberation of nitrogen gas. Here one important point is noted, you children, that commercially on the large scale the nitrogen is produced by the liquefaction and the fractional distillation of air, because as we know that the air is the mixture of many gases, oxygen, and the large quantity it consists of the nitrogen gas. So, commercially nitrogen gas is basically produced by the liquefaction and the fractional distillation of air. As we know that the liquid nitrogen having the boiling point 772 Kelvin, which distills out first, leaving behind the oxygen, because the oxygen has the boiling point 90 Kelvin. After that children, next is the important properties of dinitrogen. So, you see in the slide, this is the slide of the properties of dinitrogen. So, first is the dinitrogen is a colorless, odorless, tasteless and non-toxic gas. Nitrogen atom has two stable isotopes, that is N14 and N15. Next is it has very low solubility in water. The nitrogen gas is very low soluble in water as compared to the oxygen. The nitrogen has very low freezing and boiling point. It is inert at room temperature, means inreactive at room temperature, and this is very important that why nitrogen is inert at room temperature. This is due to the fact that the nitrogen has high bond dissociation energy due to the presence of the triple bond between nitrogen and nitrogen. That is why the nitrogen is very unreactive at room temperature. However, the reactivity rapidly increases with rise in the temperature. At high temperature it forms ionic nitrides with some metals and covalent nitrides with non-metals. The examples are given. When it reacted with the magnesium, it formed the magnesium nitride, then lithium, lithium nitride. It also combined with hydrogen at 773 Kelvin in the presence of catalyst. That process is very important and named as the Haber's process for the preparation of ammonia. So, this is very important preparation for the preparation of ammonia. Next is what are the usefulness of the dinitrogen, where the dinitrogen is used. So, first is it is used in the manufacture of ammonia and other nitrogen containing compounds, example calcium, cyanamide, nitric acid, etc. Liquid dinitrogen is used as a refrigerant to preserve biological materials and food items. It is used to produce inert atmosphere in industries, and this dinitrogen is also used in cryosurgery. After that children, the next is, after the dinitrogen, the next there are some important compounds of dinitrogen, and in this the first is the ammonia. Ammonia having the formula NH3 and NH3, and the structure of the ammonia is, it consists of 3 bond pair and 1 lone pair. So, this is the structure of ammonia having the hybridization sp3, and the shape is pyramidal shape. The shape of the ammonia is pyramidal in shape, having the hybridization sp3. It has 4 electron pairs. Out of these 4 electron pairs, the 3 pairs are bond pair and 1 is lone pair. So, basically the ammonia is present in very small amount in air and soil, where it is formed by the decay of nitrogenous organic matter such as urea. So, the reaction regarding the preparation of ammonia, that is it is present in the soil as well as in the air, and here it is formed by the decomposition of nitrogenous organic matter. After that, the next is the compounds of dinitrogen. In this, the first is ammonia. Ammonia having the formula NH3, and the structure of the ammonia, it has 3 bond pairs and 1 lone pair. The ammonia has the hybridization sp3 and having the shape pyramidal shape. Okay. So, children, as we know that that the ammonia is present in very small amount in air as well as in the soil, where it is produced by the decay of the nitrogenous organic matter such as urea. So, the urea undergo the decomposition along with water. So, this is the formula of urea, NH2CuNH2. After the decomposition is give ammonium carbonate, and this ammonium carbonate after the thermal decomposition it give ammonia, carbon dioxide and water. So, in this way in the soil as well as in the air, the ammonia is prepared by the decay of nitrogenous organic matter like urea. So, by this method the ammonia is present in our atmosphere as well as in the soil. Next is in the laboratory, how can we prepare the ammonia? So, in the laboratory basically the ammonia is prepared by heating a mixture of slag lime, calcium oxide and ammonium chloride. So, when the ammonium chloride is reacted with slag lime, it gives the calcium chloride along with ammonia plus water. So, ammonia is also obtained by another method also, that is the heating of the ammonium salt, that is the ammonium sulfate. Ammonium salts with base on small scale which decompose when treated with caustic soda or calcium hydroxide. So, here children you see this is the salt of ammonium, and this ammonium sulfate when treated with the base NaOH and then this give the ammonia, H2O and sodium sulfate. So, these are the important preparation for the preparation of ammonia, and basically on the commercial scale and industrial scale we prepare the ammonia by one of the important method that is named as the Haber's method. So, on large scale the ammonia is manufactured by the Haber's process. So, this is the Haber's process, and in this Haber process the nitrogen and hydrogen combine, this is the equilibrium forward and backward reaction to give the ammonia. So, children, as we see that in the forward reaction we see that the value of delta H comes in the negative. So, what we come on the conclusion that in the preparation of ammonia by the Haber's process we find that the forward reaction is exothermic in the nature, and which is proceed with decrease in the number of gaseous moles, because here the gaseous number of moles is in the case of reactant 4. 1 plus 3 4, where in the case of product only 2. So, the forward reaction is exothermic in the nature and proceed with decrease in the number of moles of the gaseous molecules. Therefore, according to Lake-Atelier principle, what is Lake-Atelier principle? According to Lake-Atelier principle means when we provide some stress in a chemical reaction, the reaction proceed either in the forward direction or in the backward direction in order to minimize the stress. So, the forward reaction is favorable at very low temperature and at very high pressure. So, hope you understand this children. Here this is the Haber's process. With the help of the Haber process we prepare the ammonia, and in the reaction we see that the value of delta H is in the negative. So, children, since the forward reaction is exothermic in the nature, so and it also proceeds with decrease in the number of moles of the gaseous molecules. So, children, according to Lake-Atelier principle, the condition for the forward reaction is low temperature and high pressure, because here we are taking the gaseous reactant. The nitrogen is also exists in the form of gas, hydrogen is also gas. So, when we apply very high pressure and the temperature must be low, in this condition the forward reaction is favorable according to the Lake-Atelier principle. So, this is the preparation of the ammonia by the Haber's process. This is the picture of the Haber's process, children. You see in the picture that the dinitrogen is passes through one side and dry hydrogen is passes through one side through compressor, and here the catalyst is iron oxide along with the aluminum oxide and potassium oxide. Then after that it undergo the combination and nitrogen hydrogen combine to give ammonia, and that ammonia is again liquefied and it get condensed in a container. In this way, by the Haber's process we can prepare the ammonia. This is the structure of ammonia. In this you see it has 3 bond pair and 1 lone pair, and the bond length is between the nitrogen and hydrogen is 107.7 picometer, and the bond angle is 107.8 degree, and the structure of the ammonia is pyramidal shape. After that children, next is the important properties of ammonia. So it is a colorless gas with a pungent smell. Freezing and boiling point of ammonia are 198.4 Kelvin and 239.7 Kelvin respectively. Ammonia has higher melting and boiling point than expected on the basis of its molecular mass, as ammonia molecules associate through hydrogen bond, because the nitrogen is the electronegative element, so that the ammonia molecules are associated through the intermolecular hydrogen bonding. Ammonia is extremely soluble in the water and its aqueous solution is weakly basic due to the formation of OH minus ions, and the reaction is the NH3 plus H2O, it gives the ammonium along with the liberation of OH minus ion. So that's why the aqueous solution is weakly basic in the nature, because it liberates the OH minus in the aqueous solution. The ammonia also combines with the compounds to form the ammonium salts with acid. For example, when the ammonia combined with HCl acid, hydrochloric acid, it gives the salt that is the ammonium chloride. Next is the ammonia act as a Lewis base. How the ammonia act as a Lewis base children? You see, you go to the previous picture that in the case of the structure of ammonia, that the ammonia has one lone pair of electron above the nitrogen atom. So that's why due to the presence of the lone pair of electrons on the nitrogen atom of ammonia molecule, the ammonia act as a Lewis base, because Lewis base is a molecule which has tendency to donate its lone pair of electron to another molecule. So children, next is what are the important uses of ammonia? So there are some important uses of ammonia. It is used as a reagent in laboratory. Next is it is in the industrial manufacture of nitric acid, in making urea, ammonium salts and fertilizers. Next is artificial silk tear gas is also used in making explosive material, ice, etc. So these are the important uses of the ammonia. After that, the next important topic is the oxides of nitrogen. So children, here is a slide that you see the resonating structures and bond parameters of some of the important oxides of the nitrogen. So first is the nitrous oxide having the formula N2O. So in this the nitrogen has the oxidation state +1. Physical property of the nitrous oxide N2O is the colorless gas and neutral, and it can be prepared by the reaction, that is the ammonium nitrite when heated, it gives the nitrous oxide plus water. So this is also named, this nitrous oxide is also named as the dinitrogen monoxide or the nitrogen 1 oxide. In the bracket we write the Roman numeral 1 oxide, means it has the oxidation number, nitrogen has the oxidation number +1. Second oxide is the children nitric oxide having the formula NO, which is also named as the nitrogen monoxide or the nitrogen 2 oxide. In the Roman we write 2, that because here the nitrogen has the oxidation state +2. Physical property, it is a colorless gas and is a neutral, and it can be prepared by the reaction. You can see in the slide the preparation, that is the ammonium nitrite is reacted with ferrous sulfate plus H2SO4, it gives ferrous sulfate plus sodium hydrogen sulfate plus H2O plus nitric oxide. Next is the dinitrogen trioxide, that is the formula is the N2O3, and in this the nitrogen has the oxidation state +3, and it is also named as the nitrogen in the bracket 3 oxide. It is a blue solid and acidic in the nature, and the preparation is, that is the NO nitric oxide along with the reaction with the N2O5 dinitrogen tetraoxide, it gives the 2 moles of dinitrogen trioxide. Next is the oxide, next oxide is the nitrogen dioxide, and it is also named as the nitrogen in the bracket in the Roman numeral 4 oxide, because here the nitrogen has the oxidation state +4. It is a brown gas and acidic in the nature, and it basically it is prepared by the thermal decomposition of lead nitrate, and it produces the nitrogen dioxide plus lead oxide plus oxygen gas. Next important oxide is the nitrogen tetraoxide having the formula N2O4, which is also named as the dinitrogen tetraoxide. Okay, and it is also written as the nitrogen 4 oxide because here the nitrogen has the oxidation state +4. It is also a colorless solid and this oxide is acidic in the nature. It is prepared by the dimerization of nitrogen dioxide, that is the 2 moles of N2O2 when combined together it gives the nitrogen tetraoxide. And the last oxide is the nitrogen pentaoxide having the formula N2O5 and it is written as the nitrogen 5th oxide, 5 oxide in the Roman numeral because here the nitrogen has the oxidation state +5. It is a colorless solid and acidic in the nature and it is prepared by the reaction, that is the nitric acid reacted with the phosphorus oxide P2O5. It gives the dinitrogen pentaoxide along with the metaphosphoric acid HPO3. Children, these are the important structures of these oxides. You can take the snap of this slide that these are the important structures of the oxides of the nitrogen. Next important compound of nitrogen is nitric acid having the formula HNO3. So children, basically the nitric acid is one of the most important reagent for the laboratory as well as for the industrial application for the manufacture of different types of compounds. So children, first we discuss about what are the important methods of the preparation of nitric acid. So first is in the laboratory the nitric acid is prepared by the reaction of sodium nitrite NaNO3 or at the place of NaNO3 we can take the potassium nitrate KNO3. Okay, and when it reacted with the concentrated sulfuric acid H2SO4, then after it give the product, that is the sodium hydrogen sulfate plus HNO3. So this is the method of preparation of nitric acid in the laboratory, and basically this reaction is carried out in a glass retort, and after that the vapors of the nitric acids are condensed in the form of liquid ammonia. So this is the preparation, lab preparation of the nitric acid. Second is on the large scale the nitric acid is prepared by the Ostwald process, and in this Ostwald process, this is the Ostwald process. This is Ostwald's process, and by using this process we prepare the nitric acid on large scale. On industrial scale the nitric acid is prepared by the Ostwald process, and in this Ostwald process the platinum rhodium is acting as one of the important catalyst. So children, in this Ostwald process it is basically based on the catalytic oxidation of ammonia NH3 to form the nitric acid. Okay, and this reaction is carried out in 3 steps. So in the first step the ammonia undergo oxidation, catalytic oxidation in the presence of the catalyst platinum rhodium and near about temperature 500 Kelvin and pressure is 9 bar, and it gives the nitric oxide along with the liberation of water molecule, 6 moles of water. In the next step again this nitric oxide undergo oxidation with oxygen, and in this oxidation this nitric oxide is converted into nitrogen dioxide, and in the last step this nitrogen dioxide is dissolved in, or this nitrogen dioxide is absorbed in the water, and after that the chemical reaction is carried out and it gives the nitric acid along with the liberation of nitric oxide. So this is the Ostwald process, and it is very important process for the manufacture of the nitric acid, and basically it is a catalytic oxidation of ammonia to produce the nitric acid. So this is carried, again I would like to explain this. This take place in the 3 steps. First step is the catalytic oxidation of ammonia with the help of atmospheric oxygen to give the nitric oxide. This nitric oxide again undergo the oxidation with oxygen to give the nitrogen dioxide, and this nitrogen dioxide in the third step it dissolve in water, or this nitrogen dioxide is absorbed in water, and after that it is converted into the nitric acid along with the liberation of nitric oxide. So this is the important method for the preparation of nitric acid. Next important thing is, what are the important properties of the nitric acid? So children, you see in the slide, that is, these are the important properties of the nitric acid. That is, the nitric acid is a colorless liquid in its pure form and become yellow due to the presence of NO2, nitrogen dioxide, present as an impurity and make it impure. Laboratory grade nitric acid contain 68% of nitric acid by mass and has a specific gravity of 1.504. Nitric acid behave as a strong acid in aqueous solution, producing nitrate and hydronium ion. Nitric acid is a very strong oxidizing agent which attacks on many metals except noble metals such as gold and platinum. It is very important, children, that is, the nitric acid is a very strong oxidizing agent and it attack on many metals except the noble metals like gold, platinum and silver. The chemical properties of the nitric acid, children, and the product of oxidation, since the nitric acid is acting as a strong oxidizing agent, so the product of oxidation depends on the concentration of acid, temperature and the nature of the material which is undergoing the oxidation process. So here, children, this is the first reaction. Here, when the copper is treated with nitric acid, and here we take the nitric acid dilute form. So in this reaction it gives the nitric oxide NO along with the copper nitrate and H2O. Next is, when we are taking the concentrated nitric acid, then it gives the, along with this product it gives the nitrogen dioxide. So the product of oxidation depends on the concentration of the acid, temperature and the nature of the product which is undergoing the oxidation process. After that, children, the zinc also react with the nitric acid and it gives two types of oxides of the nitrogen, that is the N2O, dinitrogen oxide, and nitrogen dioxide. So here you have to note it down, children, that when the zinc reacted with dilute nitric acid, it gives the oxide of the nitrogen, that is N2O, okay, along with the zinc nitride and H2O. Second, when the zinc is treated with concentrated nitric acid, then the main product of the oxide of the nitrogen is nitrogen dioxide along with the liberation of the same product. So zinc also react with the nitric acid and the product, means the oxide of the nitrogen, depends on the concentration of the nitric acid. After that, children, next is the some metals like chromium, aluminium, they do not dissolve in the concentrated nitric acid due to the formation of some layers of the oxides on its surface, and the nitric acid also reacted with some non-metals. For example, it reacted with iodine to form the iodic oxide. These are the important reactions of the nitric acid. When it reacted with the iodine, it formed the iodic oxide. When it reacted with the carbon, it gives the carbon dioxide along with the dinitrogen oxide. Then it reacted with sulfur non-metal nitric acid, it gives the sulfuric acid plus nitrogen dioxide plus 16 moles of water. Again it reacted with phosphorus non-metal, it gives along with 20 moles nitric acid combined with phosphorus, it gives the H3PO4 phosphoric acid plus nitrogen dioxide and water. Here, children, one important thing is noted, that when the nitric acid reacted with HCl, 1:3 ratio of nitric acid and HCl is present, that mixture is named as the aqua regia. And when these two compounds are acids are reacted together, it gives the product, that is the nitrosyl chloride. NOCl is the nitrosyl chloride plus water plus chlorine. So children, this is all about the group 15 elements. Hope you understand the group 15 elements, and in this the important is the chemical trends, physical trends of the group 15 elements, electronic configuration, then dinitrogen, and two important compounds of the nitrogen. One is the ammonia and another one is the nitric acid, and here you have to study the properties, chemical properties, physical properties, preparation of these compounds and the oxides of the nitrogen. The structure for this session is related, children, and so you have to study the main formula of the oxides of the nitrogen, how they are prepared, what are the oxidation state of the nitrogen in these compounds of the oxides of the nitrogen. Hope you children understand these topics.